Assalamualaikum and good day. For today, CMA422 structural design. We're going to learn for example number 1. You can refer to your notes for the question. A reinforced concrete beam which 300 mm wide and 600 mm deep is required to span 6 meter, which this one referring to the length. The beam carries that 25 kilonewton per meter and imposed load 20 kilonewton per meter. So for that load, annotate as GK, and for imposed load, we're going to annotate it as QK. Assuming FCU, this one referring to the strength of the concrete, Fy referring to the strength of the bending reinforcement ataupun main bar ataupun main reinforcement, and Fyv referring to the strength of shear reinforcement ataupun link, and the exposure condition is mild, meaning this one refer to the concrete cover. Design the bending reinforcement means actually this question, bila kita belajar pasal design, obviously dia akan minta kita sketch. Okay, in order to do so, first we going to need to understand the question first. Okay, so the cross section already given. Okay, H ni means the total depth ataupun the total height dia. B tu meaning berapa lebar dia, and the span meaning panjang beam tu adalah 6 meter. Beam ni carries that load 25 kN per meter, means it come from the above floor lah, whether it comes from the slab above ataupun kalau above kita ada roof dan the load come from the roof. And imposed load ni perhaps kalau slab there is human kan, human yang transfer the load daripada the slab. FCU 30 Newton over mm square, meaning that kalau kita refer to the jadual concrete which is here, concrete grade, it says here, and if you look at this, you akan nampak lah when it says that the FCU is 30 Newton over mm square, it means that the strength at 28 is curing. So C30, inilah concrete grade dia. So depends kalau 7.5 meaning the strength is 7.5 Newton over mm square. Then there is Fy460, meaning this is a high tensile steel ataupun high yield steel, which we can refer to our notes also. This one referring to the high tensile steel yang ada bunga or like corrugated surface. Okay, ini biasa kita nampak kat side, ataupun like this one which is smooth, this one, ini adalah mild steel. Okay, ini adalah high tensile or high yield steel. For Fy460, it refers to the Fy460. And for mild steel, okay, Fy is 250. Okay, so ini you have to remember lah, meaning the strength dia lebih rendah for mild steel, and for the high tensile steel it has a higher tensile strength. Therefore, if you look at this question, you know that when it says FY460, it refers to high tensile steel. And kita akan annotate when kita design this one as T, which is high tensile. And for mild steel, for 250 Newton over mm square, ini adalah untuk shear reinforcement ataupun link, we're going to annotate it as R. Okay, but first let me show which one is high tensile and which one is sorry. But first, let me show which one is the main reinforcement ataupun bending reinforcement ataupun main steel. Okay, dan lagi satu we have link ataupun shear reinforcement. For example, this is the cross section area of the beam. Okay, you might have a beam like this, which is the rectangle, dan dia akan memanjang lah kan. Okay, and then you akan have the main reinforcement down here. For example, ada 3 biji numbers, 3 numbers. Right, so this main reinforcement, dia adalah bar, so dia panjang, memanjang ke sana lah. And you also have a shear reinforcement ataupun link. So link ni the one yang berpusing. Okay, dia bukan ada satu lah, dia ada banyak. This one is for the sake of to resist the shear, and also is a to ikat to connect all. Meaning you ada bar kat bawah ni, and to avoid shear then you have this link ataupun we call it as shear reinforcement juga. Okay, so ini kita boleh panggil dia main bar, main steel, or bending reinforcement, ataupun main reinforcement pun boleh. And for this one yang banyak berpusing-pusing-pusing, we can call it as link or shear reinforcement, which is sama lah. So in our case here, kita akan just design for bending reinforcement saja. However, we still need some info about the shear reinforcement in order for us untuk design lah. Okay. Okay, and given, okay, this one referring to the diameter of main steel ataupun main bar tu, ataupun bending reinforcement, and diameter prime referring to the diameter of shear reinforcement or link. Let's start design. First, we need to calculate the loading. And in order to do so, we have to refer to the question again. Okay. And in the question, it did not include the value, okay, with the self-weight of the beam. Because we must remember, when we want to design for any structural elements or structural components, we must also include the weight of the structure itself. Meaning sekarang kita tengah kira for beam, then we need to calculate the self-weight of the beam. If it's mentioned in the question, then you don't need to calculate. Meaning you can just take the dead load and continue your calculation lah. And in this question, tak ada mention, it did not say anything about the value of GK ataupun dead load to include self-weight, means that we have to calculate. Therefore, here, it says 0.6 times 0.3 times 24 kilonewton per meter cube. This one, 24 kilonewton per meter cube is unit weight of concrete. It is fixed lah. Means that 1 meter cube, it is equivalent to 24 kilo Newton. So 1 meter cube berat konkrit adalah 24 kilonewton. However, in our case, the volume of concrete is not exactly 1 meter cube. It is 0.6 times 0.3 times 6 meter. Okay. Tapi, look at here, I tak ada darab dengan 6 meter cube ni. Sorry, 6 meter. I tak ada darab dengan 6 meter sebab kita nak biarkan dia dalam kilonewton per meter dulu. Okay, therefore kita just darab je dengan cross section area which is 0.6 times 0.3. This one ya, tukar to meter. Sebab kita nak darab dengan 24 kilonewton per meter cube. So meter cube, so everything must be in meter lah. Okay, tak boleh lah ada millimeter and then darab millimeter and then darab kilonewton per meter cube. Dia tak sama So kalau meter, kita kena darab dengan gang dia which is meter juga. Then we get this 4.32 and we can get the total value of GK which is from the question that 25 kilonewton per meter pluskan dengan self weight dia. Then you get the total of that load. And the imposed load, you just tulis kat sini supaya menyenangkan you kira. That's it. It's just from the question You just use the ultimate load ataupun ultimate design load. Dia adalah benda sama ataupun loading lah. Okay. 1.4 GK plus 1.6 QK. Okay. Where I get this, it is from your notes. Let me show you. Okay. Here. GK. Okay. Kalau you nampak, dia ada tulis ya Allah, lauzinya. Aduh. If you look at here, inilah daripada notes you sendiri which is the load we call it as GK. And for imposed load we call it as QK. And for the wind load we call it WK. But since in our design, kita just design a simple beam design, which means this is not bangunan bertingkat-tingkat sangat lah. Bukan bangunan tinggi that might have will be affected by the wind. Right, so here, if you see, okay, where did I got the 1.4 and 1.6? It comes from this table. Semua table or any references that referencing that we did for the example, and all for our design, we refer to British standard. Okay, this one lah. Okay, so kita memang semua refer pada British standard. Jadi formula macam ini. Okay, so kita akan ambil adverse directly for that load and imposed load. Therefore, this is the formula 1.4 GK plus 1.6 QK and just fill in the value of GK, the new one that you dah kira include the self weight 29.32 and the imposed load 20 kN per meter according to the question, and you will get the answer here. Right, so that is our ultimate load, meaning this is the load that going to be carried by the beam. Okay, termasuk self weight dia. Macam you lah, you carry your own weight. Next, we go to the main steel. This is where we going to design the main reinforcement ataupun bending reinforcement. M equal to WL square over 8. This is formula yang I rasa I dah explain in timber beam design, whereby if you have any load yang UDL along the length of the beam, therefore when you draw the SFD, you will get something like this, and the BMD will get something like this. And this is the maximum value M max, which is this one lah. Tak perlu kita nak draw the maximum, tak perlu kita nak draw the shear force and bending moment diagram, we can just take this formula. But make sure that it is UDL and it is along the length of the beam. Tak ada terputus-putus. Right. W is the ultimate load itself, which means this one. Ya, ini adalah W. Masukkan saja and then darab dengan the length, which is 6 meter given the question. The span, okay. Bagi dengan 8. Okay, so you dapat 328.716. Ini adalah maximum bending moment. Next, okay, kita ignore dulu this one. Ignore dulu, tak payah tengok lagi. Okay, you tengok dulu MU. So, MU di sini, apa beza dengan M? So, M here, it means that the load yang, M here means that the moment yang produced by the load. Okay, jadi itu yang di-carry oleh beam. Itu yang datang, yang transfer ke beam, yang beam tu kena carry. Okay. MU here referring to ultimate moment resistance. Meaning, bila you design, if you use the dimension ataupun besar, area dia besar macam ni, maksudnya design beam macam ini, jadi inilah, sebanyak inilah yang that beam boleh resist. Okay, dia takkan sebanyak inilah the beam boleh resist. Therefore, we must make sure that M is less than MU. Okay. Kalau lebih besar, maksudnya M boleh lebih besar dari MU, meaning that load yang ditransfer ke beam ataupun beam tu kena carry load yang lagi banyak daripada apa yang dia boleh resist. Okay. Jadi kalau terlebih, kita kena provide something else lah. Macam tu Okay, tapi in order untuk kira this MU, okay, we need to look at the formula here, which is 0.156 FCU BD squared. So 0.156 times FCU, okay, this is the strength of the concrete given. The B 300 given. Okay, however D here we don't have it. Sebab kita hanya ada H, which is the total height ataupun total depth of the beam. D here referring to the effective depth. It's not the same Effective depth referring to the, okay, if you look at gambar ini, from the very top of the beam up until the centroid of main reinforcement, that is D. For H, daripada atas sampai bawah lah. Ini H. Okay, so D adalah effective depth, H adalah total depth ataupun total height. Then we need to get the value of D lah, since it is not given. Dalam soalan hanya bagi the value of H. Right, so I will show you how. If you look at your in your own notes, and I think in page 32, you can see this is the cross section of the beam. Okay, H means that from the very top up until the bottom here, this is H. Okay. And D dia sampai centroid sahaja, means sampai sini. Right. So, kalau kita nakkan value of H, maksudnya macam mana kita nak dapat daripada atas ke bawah. Okay, tapi kita sebenarnya nak D kan. Tapi it's okay, kita kena faham the concept first. So, D, okay, dia akan plus dengan separuh daripada main reinforcement. Kita ada separuh di sini. Kan? Sebab dia sampai centroid je, jadi ada lagi separuh lagi yang kita kena campurkan to get the value of H. And then campur dengan diameter prime, which referring to the diameter of shear reinforcement ataupun link itu. Okay, ini ada lagi di sini. Alright, and last kali kita akan nampak ada concrete cover, which is C. Right. So, itu cara kita dapatkan H. So, kalau we want the value of D, means that H have to minus with the diameter of main reinforcement, half of it, minus the diameter of shear reinforcement or diameter of link, and minus with the concrete cover. Then we can get the value of D. And this is what we're going to do lah for to get the value of D. Okay, and look at the formula over there. Okay, so D equal to H. Okay, minus C. So sama je lah, minus concrete cover, minus diameter prime, minus diameter divide with 2. So asalnya adalah daripada HD plus diameter bagi 2 plus diameter prime plus dengan C. Okay, dan kita dapatkan D dan H tu kena tolak yang lain-lain lah. And that's what we do. So because of 25 mm diameter of main reinforcement, kita dah ada. Okay, dia dah bagi dalam soalan, use that 25 mm as what assumed by the question. And we also have the diameter of the link ataupun shear reinforcement. It also given the question. And 25 mm, since this is a mild exposure, which means that kita tahu concrete cover adalah 25 as what I have shown dekat dalam your notes tadi Where I get the value of that concrete cover 25 mm tadi, okay, it is basically from this table. If you see dalam soalan, it says that the concrete cover is mild only. The concrete is protected against the weather. So ada a few type of exposure conditions yang we must consider bila kita design. And in our case here, it says it is only mild. Therefore, we take the value of this 25 as our value, mild. And the lowest grade of concrete is C30. So normally kita akan design 25 lah. Okay, based on our condition of the weather of Malaysia Right. Then we get the value of 552.5. That is the value of D. Okay. One thing that we have to remember bila kita nak dapat 552.5, that 0.5 is not really something yang kita akan pakai dalam design kita tak akan pakai point-point ni. Okay. And especially kita akan go for numbers yang lebih tepat-tepat lah. In our case here D, walaupun saya tulis kat situ almost here, if you look at almost yang ada macam ombak atau wave tu adalah double wave almost. It is 552 walaupun dia tak tepat-tepat Okay, or you boleh juga round it down to 550. It's okay. Okay, kenapa kita tak boleh round up Okay, since if we have a beam like this, kita tak ada lagi berapa number of reinforcement yang kita akan pakai, so I just draw 3 over there. Doesn't matter. Okay, if you have from the very top up until the main reinforcement, this is 553. You put 553, and then you ada half of the main reinforcement diameter, which is 25 divided with 2, then you get 12.5, and then you ada 10 mm diameter of shear reinforcement ataupun link, then you have 25 mm concrete cover. If you add all together, campur semua ni, you akan dapat the value 600.5, which is this value lebih besar daripada our beam punya height. Total height kita 600, bukan 600.5. So kita kena fulfill whatever the question asks you to do. Question specifically mention the height is 600. Tak boleh exceed Therefore, that's why saya round down dia to 552. Or kita boleh round down to 550 without any problem. Right. So itu sebab dia. Okay, tapi kita nak round down, one thing kita mesti check As I said, MU ni lah. Bila kita kira MU, kita mesti make sure M is less than MU. For example, okay, bila kita round down 552, we still get the mu is bigger than m. So meaning okay lah. Right? So kalau you round down, for example if I use 550 pun boleh. Tak ada masalah. Okay, let me calculate. Okay. This one I bagi contoh sebab I cakap tadi kita boleh round down to 550 mm. So here, I dah kira lah. I pakai the D is 550. And you akan dapat, bila you kira, you akan dapat 424,710,000 Newton millimeter. Tapi bila kita nak compare dengan value of M, since M kita dalam kilonewton meter dan kita convert lah. Okay. So senang je, Newton tukar to kilonewton bagi 1000. Millimeter tukar to meter dan bagi lagi 1000. Then you get 424.71 kilonewton meter. So kalau you tengok MU yang you kira kalau the value of D kita round down to 550, it is 424.71. Tapi kalau you tengok MU, kalau you pakai 552 here, you akan dapat 427.804. Meaning value kita sebab D kita makin rendah, therefore MU kita pun akan turun juga. Tapi kalau kita compare dengan M, value of MU masih besar lagi dari M. Ataupun M is less than MU. Right? So tak ada masalah. Kita boleh round down to 550. Kalau kita betul-betul nak tepat-tepat tak nak pakai 552 for example as what I shown in this contoh tapi kita janganlah pakai this 552.5. Kalau you tengok dekat side pun tak ada drawing ataupun since we refer to the drawing, right? So tak ada value-value length ataupun any dimensions shown in the drawing that is ada point-point macam tu, tak ada. Right? Nombor dia normally tepat-tepat je. Okay, so I letak 552 for my example here, ataupun you boleh juga round it down to 550. Okay, so kalau you kira even if you use 550 or 552, M masih lebih besar, lebih kecil dari MU ataupun MU is bigger than M. Okay, why we need to make sure this? Okay. Sebenarnya MU di sini adalah ultimate moment resistance untuk konkrit Maksudnya keupayaan konkrit tu untuk resist compression. Okay. Sebab kita tahu konkrit memang why we combine konkrit dengan steel, because konkrit can resist compression. Steel will resist tension. Bila kita combine kan, we have a very strong component. Okay, yang boleh resist compression and tension. So, kalau concrete tugas dia boleh resist compression, so we must make sure that the ultimate moment resistance ni to resist compression, it is enough untuk resist compression daripada the loading itself. Moment yang caused by loading. So, M must be less than MU. Okay. So, kalau M is less than MU, bila you design, you memang akan dapat macam ni lah. Okay. For example, we have the reinforcement down there. We have a shear reinforcement. That's it. Okay. Kat atas ni mungkin ada bar. Tapi this one adalah hanger bar only, which is to use for connection untuk disambungkan saja, dan we call it as hanger bar. It is a small bar. Dia tak ada function untuk resist any loading. Okay, untuk resist any moment tak ada. Okay. Tapi kalau you dapat this is M less than MU Kalau M is bigger than MU, meaning that moment yang caused by the loading, okay, is bigger than what it can resist So MU kat sini maksudnya resist the compression. Therefore, bila you design, you akan dapat sama. Okay, you ada reinforcement kat bawah tu, which is the main reinforcement. However, above here, there might be another type of reinforcement, which is this one adalah compression reinforcement. Right? Bawah ni sebenarnya tension reinforcement ataupun main reinforcement lah, ataupun bending reinforcement kan. Okay, so kat bawah ni dia resist tension, kat atas ni dia kena resist compression. They have to help they have to provide some capacity untuk resist compression dekat atas, tolong the concrete lah. Okay, jadi kalau you dapat M is bigger than MU, then we have a problem. Kita kena design compression reinforcement, additional design step. Tapi in our case, we don't need, and according to your syllabus, you will not takkan dapat M is bigger than MU. Right? So, kita mesti akan dapat M is less than MU. Unless dekat sini, you round down dia terlampau rendah. Okay, contohnya, you round down dia terlampau rendah. Value of MU ni akan jadi terlampau rendah. MU akan lebih besar daripada MU. So make sure you janganlah lari jauh sangat daripada the value. Kalau you dapat soalan macam ni, you kira D, so you round down, jangan lari jauh sangat lah. Because everyone will have a different design. Depends on how actually you going to use, you going to calculate the number. You nak round down ke round up ke? Macam mana Okay. Tapi here you cannot round up Kalau you round up, obviously H takkan dapat 600. H akan dapat 600.5. Right. So kita dah compare. So we get that MU is bigger than M, or M is less than MU. Therefore, no compression reinforcement is required. Therefore, tak adalah reinforcement yang dekat atas tu. We can design it as singly reinforced concrete beam. Singly here referring to this one lah. Ini adalah singly. Ini adalah doubly reinforced concrete beam. Meaning that dia ada atas dan bawah reinforcement. Yang ni kat bawah ni saja yang resist the moment. Okay. Kalau ini atas dan bawah. Okay. So that's about the M and MU. Right. Then next step is we're going to calculate the value of K. So K here, it doesn't have any names. Tak ada, kita just annotate as K. It's like a factor lah. So K is equal to M over FCU PT squared. That is the formula. You can refer to your notes. Right. So M, just take the value of the maximum bending moment, which is 328.716. Divide with the FCU, 30 Newton over mm square. This is given dalam soalan the strength of the concrete. 300 the breadth, and if you use 552, then masukkan 552 as the effective depth. Kalau you pakai 550, then use 550. So in my calculation, like daripada A sampai Z, I will use 3 decimal places. So kalau kat sini dapat 0.12, yalah, kalau 3 decimal places you round it up lagi, you akan dapat 0.12 kan. So pun boleh lah. Okay, tak ada masalah. Asalkan dia 3 decimal places, you will get this value. Okay, just in case if you use 550 as the value of D, you will get a different value Okay, yang tu, that one you boleh try on your own Okay, so here you calculate the value of Z. So Z here means lever arm. Masukkan saja formula, gantikan the value of K yang you dah kira here inside this formula. Okay, you akan dapat 0.842 D. Okay, so D here means sebab kat sini ada darab D. So leave it there. Tak perlu replace dengan value of D lagi. Okay, sebab D here you nak comparekan dengan this 0.95 D. Okay, what does it mean? Kenapa nak compare? So this is according to VS lah. So kalau you dapat 0.842 D, which is less than 0.95 D, it means that bila you proceed to kira the steel area, right, as here, you akan terus pakai value ini. Tapi kalau you dapat for example 0.961D, for example, kalau you get all of a sudden it is bigger than 0.95D, when you calculate for AS later on, you akan pakai this value instead untuk kira AS dalam formula dia you nak masukkan Therefore, that's why kita have to compare with this 0.95D to ensure that the value of Z kita dapat, it is less than 0.95D. Kalau terlebih, kita pakai 0.95D instead. Right, and at the same time, I lupa pula juga, di sini pun kita kena compare dengan 0.156. Which one? This one refer to K prime. So, K prime ni adalah maximum value for singly reinforced concrete beam. Kalau you dapat, you kira M less than MU, okay, you memang confirm akan dapat value of K akan less than K prime. Okay, tapi kalau you dapat M, it is bigger than MU, value of KU akan lebih besar dari K prime. Dan kita tak nak design as doubly Doubly tu tak masuk dalam syllabus. Kalau kita design as singly, we going to get this kind. Okay, dia akan less than the K prime. Okay, next, kita calculate the steel area. Okay, masukkan je formula M divide with 0.95 FYZ. Okay, M here is the ultimate bending moment tadi, ataupun maximum bending moment 328.716. Okay, and it is in Newton mm sebab bila kita kira, kita kena make sure that semua unit mesti sama. Kalau kilonewton pakai kilonewton, kalau newton pakai newton. Jangan ada newton dan ada kilonewton masuk dalam satu equation. Cannot Okay. So 328.716 times 10 power of 6 Newton mm divide with 0.95 according to the formula. Okay, Fy is the strength of steel ataupun strength of the main reinforcement kita, which is kita dah tahu it is a high tensile tadi. So Fy dia dah bagi dalam soalan 460, and you have to ingat sebab mungkin dalam soalan later on perhaps dia tak bagi value of Fy, dia just state Fy is a high yield steel. So you pun tahu Fy dia 460. Okay, bila dia kata main reinforcement, main bar is high yield steel, so you know that is a high tensile atau high yield steel. Fy 460. And the value here, ini adalah Z. Oh, dekat sini baru you darab dengan D sebab you dapat 0.842D kan. So 0.842D 552. Kalau you pakai 554, use 554. Right. Then next, what we going to do, we almost reach the end of the example 1, but kita kena dapatkan number of bar, size dia apa, dan kena sketch sampai habislah. Okay, so kita tahu the diameter that we have to use for the main reinforcement is 25. Therefore, we will refer to this cross section area of round bars. Okay, ini adalah standard size for shear, for the reinforcement. Ini adalah standard, keluar dari factory macam ini. Tak kisahlah mild steel ataupun high tensile steel. Okay, so bila kita tahu 25, so kita highlight 25 lah. Which one kita nak pakai? Refer to the value of AS, which is 161 when 8.409 mm square, then put up here 0.409. So value AS ni adalah minimum This is the minimum value yang kita kena letak. Jadi the value yang kita choose for the area untuk steel mesti lebih besar daripada this AS So the nearest for the bar size 25 is 1960. So how we going to write this one? it's 4 numbers. Okay. And high tensile or high yield, T tadi, 25 mm diameter. So inilah bar yang kita nak pakai 4025. Right. Di sinilah. Then I put the AS yang saya dapat daripada the table tadi 1960. Okay, the next step is we need to calculate the spacing sebelum kita boleh draw. Okay, nak make sure that the spacing is enough. What does it mean with the spacing? So spacing ini yang saya highlight ni lah. Berapa spacing between bars? Macam mana kita nak kira? Alright. So spacing here means spacing antara bar tu kan. Jadi first apa yang kita ada is the width of the beam, which is 300 mm. Okay, so put 300. Right, so bila kita tolak minus, kita nak tolak area yang lain-lain supaya kita dapat spacing yang kat tengah tu je. Right, so kita tolak bar ni, this bar, main bar. 4 numbers tadi, remember? So 4 numbers of 25 sebab kita dah select bar. And then kita ada link. Okay, link 2, kanan dan kiri. Therefore ada 2. Sorry, not referring to this one. Link 2. And 10 mm means the diameter of link. And this one given dalam soalan dia dah suruh assume diameter prime tadi, diameter of shear reinforcement. Kanan dan kiri size dia 10 mm ada 2. And we have 2 concrete cover kanan dan kiri. And the concrete cover is 25 mm. Kita dah dapat tadi sebab kita mild exposure. Alright. And bahagi dengan 3. Kenapa bagi 3? Sebab kita nak 1 je. Berapa ni? Okay, so kita ada 1, 2, 3 spacing. Jadi kita kena bagi dengan 3. Nak senang, mungkin you tak dapat 4 numbers of bar. Jadi macam mana kita nak tahu berapa spacing tu? So, you ambil je number of bar bahagi 1. Tolak 1. You akan dapat 3. So 4 minus 1 you get 3. Kalau you ada 5 numbers of bar, so 5 minus 1 bagi 4 lah. Okay. Bila you kira, you dapat lah 43.333. Alright. So value ni mesti lebih besar daripada HAGG plus 5. So HAGG tu adalah maximum size of aggregate. Normally untuk building, kita akan pakai aggregate yang paling besar dalam campuran konkrit tu adalah 20 mm. So dia takkan lagi besar lagi lah. Okay. So 20 campur 5 you akan dapat 25. So kalau kita compare this 43.333, it is bigger than this 25. Therefore okay so you boleh tulis lah okay. Okay, so baru boleh draw. Here the sketch To sketch this one, what you need is you need the numbers of you need the dimension itself. Okay, 300 the breadth, right? And then you have the effective depth 552. Kalau you pakai 550, put 550 lah. And you have 4 numbers of main reinforcement. You have link, which it is R10 link. R here referring to mild steel tadi. Dia dah bagi tahu FY untuk link adalah 250. So kita tahu dia mild steel, so R. And 10 ni 10 mm diameter given the diameter prime tadi 10 mm. So 10 tu refer to diameter dia, right? And 2T12 hanger bars ni, ini 2T12 tu assumption saja. So hanger bars dia tak ada any function yang ni 2 biji ni. Right? Dia tak ada function untuk support any load ataupun support any moment. It just for connection purpose only. Right? And Okay, 48 ni mana saya dapat? Okay, sebab D kita adalah 552. Okay, kalau you tahu effective depth, kita punya depth total adalah 600. So 600 minus 552, you get the balance of 48. Okay, so kalau you pakai 550, down here you get 50. So itu yang kita kena label lah according to what I draw here. So that will be all for example number 1. If you have any question, you can always contact me via WhatsApp or comment in I discuss or any other platform yang mana you dapat contact saya. Okay, thank you so much everyone. Have a nice day.